Okay, AP Stat, here's your second video on experiments. We are going to talk about the 4 principles of experimental design, and then I'm going to work some examples for you. Examples, where was that word in my head? All right, so the 4 principles of experimental design. These are just 4 things that we need to follow, and your book does speak of the 4th principle differently. It gives it as blocking, and that is not what we're going to do. Mrs. Burnett and I discussed it, and we compared that with the College Board information, so our 4th principle is different than it is in the book if you're reading the book. Okay, so the first thing we're going to talk about is control. We need to make all of the conditions as close to the same as we can for all of the participants or the experimental units, whatever you're doing the experiment on, people or things. So by that, I mean we need to make sure that nothing that the volunteers are doing is going to confound our results. Now, we talked about this a little bit when we did linear regression. We talked about the fact that X and Y can appear to have a relationship, but a lurking variable is actually confounding your results. So we don't want anything confounding our results for our experiment. So what would this look like? Well, revisiting that example I showed you in the last video about levels and treatments and factors and all of that, if we were to have people in this experiment, we want to know how their weight responds to sleep and exercise. Well, let's say some of my volunteers decide that they're going to go on a low-carb diet in the middle of my experiment. Well, they're probably going to lose weight, but then at the end, I'm not going to know if they lost weight because of sleep and exercise or because of their change in diet. So that would be something that would confound my results. So I would want to make sure that I was controlling that as best I could. I would have to, have people agree, hey, I'm not going to go on a crash diet during this, I'm going to eat normally, etc., etc. So that's what I'm talking about when I'm talking about controls, and we're going to talk more about these in a minute. All right, the other thing we have to do is randomize. Remember, all of our participants or items need to be randomly assigned to a treatment. If you do not do this, it is not an experiment. This has to be done. There's no getting around it. If it's not done, it's not an experiment, period. All right, replication is also something that is very important when we're looking at experimental design. We need to make sure that we can repeat experiments to make sure that our results aren't by just some chance happening or by some fluke. We need to make sure that we can replicate it and see if we get consistent results each time. That's what gives us our good information. We also need to make sure that we're taking large enough sample sizes, and we'll talk more about that later. All right, comparison. We need to make sure that whatever we're measuring, we have something to compare it to. So you're not going to have an experiment where you don't have at least 2 treatments, because you always want to compare to something else. Now, the way that can look is in the form of controls. So when we look at control groups, we want to have a control group in our experiment, because our control group is going to be the group that either receives no treatment, a previously used treatment, or something like a placebo to compare something new to. So I've got an example lined up for you that's a perfect illustration of this. Also, in case you don't know what a placebo is, remember that a placebo is a fake treatment that looks like the real thing. So it would be an example of where some people know they're getting a treatment and some people know they're not, but they don't know which one they're getting. Okay, so what I mean by that is, let's say I call for 100 volunteers, and I know 50 are going to take the placebo and 50 are going to take this new treatment of some kind, and I'm going to tell them that, but I'm not going to tell them which one they're getting. Okay, so they're going to be aware that a placebo's out there, they're just not going to know they are getting it. So we'll talk more about the placebo effect in class next week as well, but for now I want to shift focus and look at our example. Whoa. So don't get a headache. I'm going to scroll down here pretty fast to example 1. All right, so in your notes, example 1, we have 100 volunteers who suffer from indigestion, and they are available to test a new indigestion medication. There are 50 men and 50 women. Okay, so part A is what we're going to look at. Design a completely randomized comparative experiment to test the new drug. Now, that's a short sentence. There's not much going on, but there really is a lot going on because it tells you some interesting stuff. Completely randomized means that all 50 men and all 50 women would get mixed up, and then I would pull from all 100 people. Okay, I don't care if so many men are in this group or so many women are in this group. That's what completely randomized means. All right, comparative, that means that's that last principle in my experimental design. I have to compare this. So I'm told that there's this new indigestion medication. As far as I know, there's just one level of medication, which means I've got to create a comparative group, so a control group of some kind. So what would this look like? All right, so I'm going to design an experiment for you, and some of you are going to be thrilled with how easy this is. All right, so I take my 100 volunteers, okay, and I distribute them to two groups. I am going to have them, let's see, I'm just going to put 50 in a control group. So 50 in my control group. Now you can assign something to the control group. You can say that they get a placebo, or they get an old form of medication or something like that. I just have to have a group to compare it to. 50 of my volunteers will get the new medication, so they're going to be a treatment group. Okay, and if this medication had different levels, like 50 milligrams and 100 milligrams, well, then I would have another treatment, and I would distribute my people evenly into three groups. All right, so remember, this is completely randomized. So these 100 volunteers are going to be randomly placed. So I'm just writing the word randomized here. Unless you're specifically told to describe your randomization, saying you're randomizing it will work. Now, if they ask you describe your randomization, well, that's when you're going to have to get creative. And we're not quite there yet, but we will be. Okay, I want you to be thinking about that, though. I want you to be thinking about what that would look like in this situation. And don't overthink it. Okay, at the end of the experiment, you are going to compare levels of indigestion. And yes, you need to use, don't just write the word compare. You need to write your context, okay? I'm comparing levels of indigestion. Guess what? That's the answer to A. That's all you got to do. That's a well-designed experiment right there, okay? Now, if you're uncomfortable with this formatting, you can write it out. You can write, I will randomly place 100 volunteers into a control group, 50 in this group, 50 in that group. You get the idea, okay? So you can write it out, or you can create it this way. It does not matter to me which way you do it. But in fact, in our current situation with people typing stuff, it might just be easier for you to describe it, and that's totally okay. So that is how you do that, okay? This next example, we're not going to do part B right now because we haven't talked about blocking yet, so we'll hit that later. All right, example 2, we have a consumer group that wants to test the effectiveness of a new organic laundry detergent and make recommendations to customers about how to best use the product. Okay, we're not testing this product against some other product, nor are we testing it against not washing something. We are testing how best to use this product. So that means all of our treatment groups will have to do with this product just how we're using that product. They intentionally get grass stains on 30 white t-shirts in order to see how well the detergent will clean them. They want to try the detergent in cold water and in hot water on both the regular and delicate wash cycles. Design an appropriate experiment indicating the number of factors, levels, and treatments. Explain how you would randomize in your experiment. Well, for now, we're not going to do that. Okay, we're just going to do the other part of the problem. So here's what I would do. I would say something like this. If I'm going to design the experiment, I'm going to write this one out, so bear with my handwriting. I know it's going to be rough. All right, so randomly distribute t-shirts to the following treatment groups. Okay, I will choose 8 t-shirts, randomly, of course. Will receive the treatment hot water, delicate cycle. 7 t-shirts will be washed in cold water, delicate cycle. Eight t-shirts will be washed in hot water, consistency, Amy. Sorry, Miss Griggs. Hot water, regular cycle, and 7, I forgot the word t-shirt. It's okay. 7 will be washed in, have I done hot delicate, cold delicate, hot regular, cold regular, right? In cold water, regular cycle. Okay, and what are we going to compare? We will compare stain removal. That's what we're comparing. All right, so it also tells us to indicate the number of factors, levels, and treatments. So obviously we have factors of water temperature and we have cycle. And then of course the levels, within those we've got hot and cold, regular, and delicate. So how many total treatments do we have? Well, we've got 4 treatments because we've got hot regular, hot delicate, cold regular, cold delicate. So that is how many treatments we would have. Now, how you write this doesn't have to be exactly like this, all right? But you have to get some important things in here. You have to talk about the fact that you're randomly distributing the t-shirts to the treatments, okay? I'm randomly assigning my items to a treatment. And then you have to tell me how many you're putting in each one. I want you to notice that some groups have 8 and some groups have 7. That's okay. They don't have to be the same. All right, and then you're telling me what we're comparing. So those are the important pieces in your description. Those all have to be there. And of course, for this particular problem, you were asked to indicate the number of levels and factors and treatments. So there are 2 factors, and there are 2 levels within each factor, so there are 4 treatments. All right, score.